Hello everyone, I am Shamsur Rahman Akash. I am doing this work under my respected supervisor Dr. Noor Hisham. Here is our objective. We will design a square patch antenna on a FR4 substrate. The frequency is 2.45 GHz and the thickness is 1.6 mm. And later on, we need to find the characteristics of the patch antenna. The dielectric constant is given as 4.7. So at first I listed down all the parameters value, like the frequency is 2.45 GHz, the dielectric constant of substrate is 4.7, the height of the substrate is 1.6, and height of the conductor is 0.035. Then I listed down all the formulas I got from different books from antenna designing. These are the formulas. Fi is the length of the feed line, and some information like the gap between the patch and the and feed line, usually 1 mm. Let me show you the feed line. Okay, this one is the gap of the patch and the feed line. This one is the feed line, and this should be 1 mm. This is usually. And here the input impedance is usually 50 ohm. It's usually 50 ohm, and let's say the microstrip feed line is showed by WF. This one is the width of the microstrip feed line. And C is the velocity of the sunlight. So now let's calculate the value of the parameters. At first we calculate the value of width of the antenna. So by substituting the parameters values, we could find the value of width, which is 36.27 mm. And as it is a square shaped antenna, so the length and width would be the same. So we get the length as well. And by substituting the value of h, which is the thickness of the substrate, 1.6, we can find the value of fi. Remember the fi, this one, we can find out the value of this one as 4.8. So then we got the value of the parameters here, which is the width is this one, fi is this one, wf, which is the width of the feed line, is 2.92, gps is usually 1, and this one is the formula I got it from the book. Lg is 2 multiplied with L, Wg is 2 multiplied with width, and this is Ht, and this is Hs, and this is the outline we just draw to make ourselves easier, comfortable with this. So now let's design using CST. This is the first window. If we open the CST software, we will see this. Then we have to create a new project here, and microwave and optical. Then click on antennas as we're designing this. Click next. We are doing a panel antenna, so click on this. Time domain, and here we need to define all the parameter units so that no complicated issues arise later on. So this is the parameter units we will use. Oh, now we have to find our frequency is 2.45, so our frequency range should be from 1 to 3, and these are the things we will like to see on our result. So let's just click on everything, and we have this specific frequency of 2.45, so let's just define 2.45 here. Okay, next. Okay, finish. Yes, this is the first thing we will see. Okay, let's calculate the impedance first. As we already written all the parameters value here, we can calculate the impedance value from here. We are using thin microstrip, and the thickness is 1.6. This is 4.7. So we have to find the perfect value of W so that we can get the impedance is 50 ohm. So by trial and error we can find, if we substitute with 2.932, we can get exactly the 50 ohm. So this is the our width of the feed line, which is WF. So 2.932. And F7 to update the table. Okay. Now let's make the ground first. To go to the modeling part, click on brick, press ESC to get the dialog box. So just like ground. Here we have written the range for the x-axis and the y-axis. So this WG is basically the total width of the substrate. From here to here is WG, and LG is from here to here. Okay, so we have already, and this one is 0.035 as a thickness. We are using copper here as a material, so the thickness of the copper is 0.035. So we are using copper as a ground. So make it okay. So this one. Okay, now we will design the substrate. So again we have to choose a brick, press ESC, and write substrate, and put the ranges of the x-axis and y-axis like before. Here all the ranges are written already. So the range is same with the previous one, because it is exactly will be on the upside of the ground. So the range is same, but the difference is within the thickness. So here our range is from 0.035 to 0.035 plus HS. HS is the thickness of the FR4 substrate. Now our antenna is looking like this. Now we have to design the patch. Like again, we need to pick a brick. Let's write PHH patch. And here all the parameters value, all the ranges are written here. So this is the patch. So to design the patch, we have to write down the specific value we get from the calculation in the range. So this one is the specific range of the width we got from our calculation. So this one is negative part from this part, and this one is this part, this one is this part, this one is this part, and we are using copper to design our patch, so that to the previous lane our thickness has been enhanced by 0.035, which is the thickness of the copper. So this. Okay, now we have to design an empty space here. So like previous, we have to pick a brick, press CSC, like space, and put all the ranges here. Here all the ranges are written, and we are using nickel here to create the empty space. We use nickel so that it will be visible here, so it will be easier to cut it off. Okay, now as we are creating the empty space, so we need to cut it off. So cut away the highlighted shape. Okay, yeah, done. So now we have to pick a brick. Now we have to actually design the feed line. So again, we have to pick a brick and press ESC, just like feed line, and then we need to write all the ranges here. So here we have written all the parameters value range here. So we have to use the copper here, because later on we will add the feed line to the patch. So the thickness of the feed line and the patch must be the same, and the material also. So we are using copper here. Yeah, we got our feed line here. So now we have to add our feed line with the patch. So in that case, we have to just click on our components, just click on feed line, then here add with the patch. Enter. Okay, now this is our antenna is looking like. So now we have to select a port. To select a port, like if we want to make it port, we select this port. So we have to press F on keyboard. Then we have to double click on this surface. This. Now let's go to the simulation tab and click on waveguide port. So this is port number 1, and actually the port size by giving the range we can design the port. The port size can be variable. So it's like here we will write 3 multiply with WF, and we get this range here. So let's click on OK. So here we already made our port. This is how our port is looking like. So now let's click on field monitor and put our frequency is 2.45. Apply. Okay. And field monitor, click again. H field 2.45. Okay. And farfield 2.45. Apply. Okay. So now everything is done here. So we can start our simulation, but before starting our simulation we need to save the file. So let's click on file, save as, anywhere you want, like choose save. Okay, now let's go to home and start simulation. It will take some time. So yeah, our simulation is done here. So to see the result of our simulation, let's go to 1D result part and click on S11 parameters. Oh, here it is. So just click on the axis marker and move marker to minimum. So we can find it, yes, our frequency is on 1.928, which is not enough. We need 2.45. So on that case, we need to change the the value of our parameters here. So after doing some try and error, so I find that if we fix our width is on 28.45 and the length, okay, and the length 28.45 and Fi should be 9 and here the width of the feed line should be 1.137. So now let's press F7 to update the table. Okay, let's do our simulation again now. Let's go to home and start simulation. Yeah. Yes, we have done our simulation again. And to check our new result, let's go to the 1D result and click on S11 parameters. Yes, now we can see that we got exactly 2.45 frequencies. And our gain is around like -21, whereas the minimum range is the maximum range is -10, and anyone less than -10 is a better result. and we are having here is -21, which is good. And from the result we can also see our VSW bar graph and efficiencies, our energy, and to see our farfield view. To see our farfield view, let's click on the farfield here and let's click on 3D. 2D is like this, and 3D let's click on 3D, and this is our farfield view of our antenna. So if you want to see the structures inside, so let's click on show a structure and farfield transform like this. And for linear omnidirectional, this is the direction. And we can see our axis from here as well. We can check also our farfield directivity ABS. Yeah, this is like this. For isotopic, it's like this. We can also see our radiation efficiency from here. This is the total efficiency. Now, in order to do the bandwidth calculation, let's go to our S1. So let's click on the curve markers, add curve marker, and just exactly on N. Another one is on here. So from here we can see our frequency for this 2 point. So in order to find the bandwidth, we need to apply a formula, which is this. This is the high frequency, this is the low frequency, and this over by the exact frequency and multiply with 100, and we get our bandwidth is 2.4. So basically we get our radiation pattern from here also. This is the radiation pattern for field plot. Yes, so we can see it from all around. So we have successfully designed our antenna. So if you need more inquiries, you can please go through these references. Thank you for watching this video.